Okay, so here comes the extra search sort algorithms that I said we'd be doing today. So we're going to start with one called the insertion sort algorithm. Okay? So like the other ones, this is a sort algorithm. So I'm going to steal a little bit of the code from up here, from any of the other sorts, and place it down here. And this time I'm going to be doing the insertion, not optimal, the insertion sort algorithm. And that's the name of the method I'm going to make, called insertion sort. Okay? Okay, so this is another algorithm we're going to put into our sort tools class called the insertion sort. So it's going to sort the array as well. So we start by scrambling the array, by recreating it. We display it in its scrambled state. We then run the insertion sort algorithm and display it sorted afterwards. Okay? So again, you don't have to type all that code. You can just copy and paste it from up here and just change a couple things with it. Okay, this is not a long algorithm, but it's got, again, some tricky logic that you got to kind of follow. I think it's only about 7 or 8 lines long. It's not that much lines of code, but it's a little bit tricky to grasp. Okay, so let's write this algorithm. Create method insertion sort. Okay, so this will be made inside the sort tools class. You should now be able to find, it should have built a method in there called insertion sort. And there it is. Okay, I'm going to put the modifier public at the front. And let's get coding. Okay, like most sort algorithms, this incorporates a loop. Okay. So we're going to have an I loop that goes to array.length. Okay, so we go from 0 to array.length. But here's the first change we make. This loop doesn't start at spot 0. It starts at spot 1. So that is a major change from a lot of our algorithms, is it doesn't start at the first spot. It starts at the second spot. Okay, so I'll sort of leave that for now. You'll kind of grasp that later. Okay. Now we make another variable, j, equal to I. So we have a second variable that's equal to I. So it's also going to be 1 at this point. We now need to hang on to a temporary value, very much like the swap algorithms. We get it from array spot I. Okay. Now remember, that's spot 1 at this point. Now, here's where it gets weird. Instead of using a for loop, we now use a while loop. While j is greater than 0, and I'm going to put that as its own condition inside its own set of brackets. So while j is greater than 0, and array spot j minus 1 is greater than temp. Okay, so it's a tricky piece of logic there to kind of grasp. We'll go through it in a minute. But make sure you code that correctly, okay? Make sure your greater than signs and less than signs are in the correct spots. Make sure it's j minus 1, not j minus I. Make sure it's j is greater than 0 and greater than temp. Okay, 3 more lines and we're done. Array, this is inside the loop. Array spot j equals array spot j plus 1. And then j minus minus. J is actually going to go down. And then finally, one last line after the while loop. Array spot j equals temp. Okay, before I explain this algorithm to you, let's make sure it works. Okay, so that's the algorithm. I'm just going to run my code. I know some of you guys are still typing. But you can see it didn't work. So I've made a logic error. What it's done is it's made negative 13, negative 13, negative 11. So embarrassing as I'm... Oh, here's the error. So silly. That should be a minus sign. My apologies. Wow, let's just make sure it works this time. Yep, now it's fixed. So that's when you can see that this kind of algorithm is really, really temperamental. Okay, so let me draw a real simple array and try and run this logic. Okay? Okay, and I'll just scramble it up. So 5, negative 2, 0, 100, negative 1. Okay. So here's how it works. It starts with a variable I, and I is a 1. And I is going to keep going while it's less than the length of the array. And this array has a length of 5. That's the length of this array. It then makes a variable j, and it's equal to I, so it's 1. It then, I'll put this one over here, makes a variable temp, and it's equal to the array at spot I. So at spot I is the value negative 2. Okay, here comes the tough logic. While j is greater than 0, well, 1 is greater than 0, so it meets the first condition. This has to be true, and this has to be true. The array spot j minus 1, well, j minus 1 is the spot before that. So is j minus 1 greater than temp? Yes, it is. This value is greater than temp. So both conditions are true, so it enters the while loop. And it says array spot j, which is that negative 2, equals array spot j minus 1. So this becomes 5, and now j goes down. J goes down to 0. Now it attempts to run the loop again. Is j greater than 0? No. So it fails the first condition. So because that's an and, there's no need to even check this second condition. And means both have to be true, so it leaves the while loop. And then it says array spot j, which is a 0, equals temp. So now the negative 2 goes here. So it looks like I've just performed a swap. But we're still not done yet. So now it comes back up inside the for loop. I goes up by 1. So now I is 2. Okay? J is now equal to I. So it's 2. Temp is equal to array spot I. So temp is now 0. Okay? Now while j is greater than 0, that's met. And array spot j minus 1, that's the 5, is greater than temp. Well, 5 is greater than temp, so it enters the while loop. Array spot j, array spot 2, equals array spot j minus 1. So this becomes a 5. J goes down by 1. Now we're at 1. Now, it meets this condition. It's still greater than 0. But is array spot j minus 1, well, j minus 1 is spot 0, which is the negative 2. Is that thing greater than temp? No. Negative 2 is not greater than temp. So it leaves the while loop. Array spot j, array spot 1, is equal to temp. So the 0 goes there. So at this point, it kind of looks like it's performing the bubble sort algorithm, but it's not. Okay? This algorithm is more efficient. I'm not going to go through the rest of it with you. But in the end, what it does is it performs less operations to sort that. And that's the insertion sort algorithm. Okay? It's not that commonly written because it is a bit of a sort of a mysterious algorithm, but it works. Okay. That's insertion sort. Now we're going to write another one. This one's also optional. And this one is called the shell sort. And where do you think this one comes from? Any idea? Where would the word shell come from in a sorting algorithm? This would be for any of you guys who've been to carnivals, maybe. You guys ever seen those guys at carnivals that have like 3 shells and they put a ball under one of them and they start mixing them around and you have to guess which one the ball's under? Don't ever play that game. They're professionals. They're going to totally take your money. But that's what that is. That's the sort of thing that's going on there. Is the shell sort is a kind of a swapping algorithm as well. Okay? Very much like the insertion sort, it's just got some tricky logic. It's about as long as the insertion sort. Okay? So now we're going to create this thing called the shell sort. So let's go do it. Okay, and we'll make it a public shell sort. Okay, this one starts off by making an integer variable called j equal to 0. Okay. Then it uses a for loop, but I'm not going to automate this one because it's a weird int gap equals array.length divided by 2. Okay, so that's a strange start to this for loop. It creates a variable called gap that starts at the midpoint of the array, because I divide it in half. While gap is greater than 0, here's again the weird logic. Gap equals gap divided by 2. So it cuts the gap in half. So it keeps dividing it by 2 each time through the loop. So a very, very strange for loop there, using a variable called gap. Now we have another for loop. This one I'll finally use I. If for int I equals gap, well, I is less than array.length, I++. So that's a more traditional looking for loop, but it starts at the value gap, which is this weird calculated value. So really what gap is doing is it's going halfway, kind of, through the list. Okay, inside this for loop, we make a temporary variable, temp, equal to array spot I. And then, believe it or not, we have another for loop, for. But here's where it's weird. Here's where we finally use j. For j, and we don't have to say int j, because we did that up here. We made j. For j equals I, inner bracket, j is greater than or equal to gap, and temp is less than array, spot j minus gap, semicolon, shrinking that, j equals j, oh, what happened there? Oh. J equals j minus gap. Okay, so nasty, nasty logic here at this point. Okay, not going to lie. And then one line inside that for loop, array spot j equals array spot j minus gap. And then finally after that for loop, last line, array spot j equals temp. Okay, I don't think I'm going to go through this algorithm with you guys. I just want to run it to just make sure it actually works, shell sort, and it does. Okay? So, believe it when I say to you guys, I did present to you some of the easier sorting algorithms. You can see the amount of mathematical formulation that went into this one, okay, is intense. Okay? It's got an intense amount of sort of for loop action going in there. Here's an extremely fancy word for you guys. Cyclomatic complexity. Oh yeah, I sound smart when I say that. Cyclomatic complexity refers to how many different ways a method can return. And it has a few more things that are part of it. This is not a return method, it's a void method. Okay? So its cyclomatic complexity is actually 0. It has, well, it's 1. It has one way to return when this method's done. Versus the example I just did with the grade 11s, some of those methods had a cyclomatic complexity of like 2 because there were 2 different ways it could return. But what actually is going on inside this algorithm is a lot of complex mathematics there based on a lot of these formulas. Okay? But something to think about. All right, how we doing? We got a little bit of time. Let's start this the very last optional algorithm. And it's called the quick sort. Okay? Now, one thing real quick, I just want to go back to that example, that animation I showed you guys yesterday. So at this point, you should be at least running your code to make sure that it is performing all these sorts. So the insertion sort is sorting it, and that the shell sort is sorting it. And again, when you take a look at this now, when you take a look at your actual class, you have a lot of really nice methods now for sorting and searching your code. Whoops. Just going to collapse them all. So we have the bubble sort, the selection sort optimal, the insertion sort, and the shell sort. You have all of those to choose from. These are all little private methods that are used inside there, but right, those are all some sort methods that you can use. You similarly had some simple search ones. So now, using that example, Java sorting animation from this website, okay, you have a lot of these. You have the shell sort, you have the insertion sort, selection, bubble. Okay, I don't have time to do the merge or the heap, but I'm going to do this one, the quick sort, not quick 3, but quick. And now again, as you look at these algorithms in action, now you have this algorithm, the sort, and look how fast that one did there or down here. It's beating the bubble sort on a lot of these things. Okay? You also have the shell sort, which is already done. So I wish this went a little bit slower so we could kind of feel, but here you can see the shell sort working away. It's done this one, this one, this one, whereas selection and bubble are still working, and even insertion is still working. So that shell sort, the last one we just wrote, is faster so far than the other ones. So I'm getting a good speed out of it, even though it's got a complex logic to it, it's got good speed. Okay? So now we'll just start this one today because we won't have time before the bell. But we're going to do one more called the quick sort. Okay? And the quick sort is a recursive algorithm. Okay? All the more why you need to kind of learn recursion before you can do quick sort. Okay? So we'll just set it up for tomorrow. I'll create the method quick sort. And by tomorrow, I mean Thursday, because I'm on a field trip tomorrow. And that will be on Thursday's agenda, is we will write the quick sort algorithm for use, okay, in this program. And that will give you guys some bonus points as you want to try it. And again, especially any of you who are going to plan on taking computer science at university, it's good to have a warehouse of these libraries ready. I know you can get them online, right? Even at this website, I think if you click on Shell, it shows you the algorithm right here. Although it's often in other programming languages or it's in pseudocode like this. I don't know if you can actually get the Java version of it on this website. Okay, so you might have to, Google it. And sometimes the web is just too large of an information source. Okay, so if I want a Java Shellsort algorithm, Stack Overflow, a great example of that for sure. You can get some of this code pulled in. But now when you go and compare it to the code that we just wrote, so there's that Shellsort, will it be easier to interpret, right? A lot of times people will try to show off their coding. So here is a snippet of code right here. Okay? And here's their version of Shellsort right there. Is that easier? I don't know. You'd have to look at it to kind of get a feel for that. Maybe it is. Keeping rolling down this article, oh, this guy says this is a simpler version of Shellsort. Okay? This one looks very similar to mine. It's using a variable gap and stuff like that. Okay? However, this uses what's called a comparable interface, which you guys don't know about. So that might leave you a little bit lost at this point. Okay? Similar with this one. A little bit more complex. Okay? This one is similar to the one I wrote with you guys, but again, maybe not quite there. Now here's one that uses an integer array, just like we did. So that one might be better. But you can see here, it uses a series of while loops to implement the algorithm, rather than a for loop. Maybe that one's an easier version. I don't know. It's certainly more lines than the one I wrote with you guys, but maybe it's easier to interpret. Only you can be the judge of that.